This is video on statics of coplanar non-concurrent forces. This is 7th video in the series, and here we are solving a truss by what is called a method of joints. Now this figure is a truss. It consists of members. At the end they are pinned with other members. You see, so all the joints are internal hinges, pin joints, and they are supported on regular external supports. This is support A is hinge, support D is roller, and all the some of the joints or all the joints are loaded as shown. Now this is very important structure. It has a lot of practical applications, like in bridges, in cranes, in roofs of the factory sheds. So because of its importance, usually this is considered as very important topic even from examination point of view. Okay, now of course, being a first course, the whole thing is very simplified. So here you see, be assured that total geometry of this truss is given to you, that all these angles and the distances are given to you, and the loads are given to you, joint loads, and support conditions are given to you, hinge and roller, and your objective is very specific. Find support reactions and find forces in each of these members, So first, in order to find the support reactions, we replace the supports by appropriate reactions, hinge by 2 reactions and roller by 1, and for the overall truss, that is external joints and the reactions, write equilibrium equations. Those are sigma fx0, sigma fy0, and sigma m0. So if I write sigma fx equal to 0, straight away we'll get HA is equal to 0. Sigma fy equal to 0 will tell me VA plus VD is 70. See, we have just added vertical loads VA, VD, and then 20, 30, and 20 are written here with negative sign because they are downwards in the negative y direction. And then we take moment about A of all these loads, including this reaction. What we get is VD into 9, this 20 into 3, this 30 into 6, and this 20 into 3. We have taken clockwise sense as negative and anti-clockwise sense as positive. So last equation enables us to work out VD, and if you substitute it here, you get VA, and thus first task we have completed. That is, we have worked out all the external reactions. Now, in order to solve internal forces by what is called method of joints, what we have to do is isolate a joint. But before that, let's call out the members, because these are the members which we have to work out. So we are calling them out: F1, F2, F3, F4, so on up to F9. 9 members, that is 9 forces we have to work out. Now isolate joint A, because we have to solve the joint A first. Now when I isolate, what we do is we take it out, but draw all the forces on this joint which were acting on it while it was in the truss. So one is HA, another is 36.67, another is this F1, and another is this F2. Now see, HA is 0, 36.67 we already worked out. F1 and F2 are unknowns at the moment, so I don't know their direction, so I assume them to be away. And this assuming away means I assume them as tensile. Now, look here, this is a situation of concurrent forces keeping the joint in equilibrium, because therefore these 4 forces together must obey sigma fx0, sigma fy0. So we use that. We write sigma fx, f1 plus f2 cos 53.13 is equal to 0. Now see, HA has to be there, but HA is 0, that's why we have not written it. And then we have sigma fy equal to 0, 36.67 plus f2 sin 53.13 is equal to 0. From this equation we can solve f2, put it here, and get your f1. Now f2, see, F2 came out negative means the force was actually like this. So as against this, if this is tension, this is a compressive force. So I have got all the information about F1 and F2. We'll transfer it to the main figure. So we have done that. F1 27.5 tension, F2 45.84 compression. Now this tension, it pulls the joint, compression, it pushes the joint, and we have written here 27.5. Tension we have indicated by T and compression we have indicated by C. Now we have transmitted this information to adjacent joints. See, it is tensile here, it has to be tensile here. It is compressive here, it has to be compressive here. So joint A has done for us whatever it could. Now we will move to next joint F. Again do the same thing. Isolate the joint, draw all the forces, assume them to be tensile F3, F4, write sigma Fx0, write sigma Fy0, work out F3 and F4, both are positive, both are tensile, fine, transmit this information in the main figure. Extend it to the adjacent joints and then move to the next joint. See, we are moving from joint to joint, every time solving two forces from the joint, and therefore this is called method of joints. Now you don't have to go to E, you can as well go to more simpler joint D. Same thing, isolate, draw forces, write sigma Fx0, write sigma Fy equal to 0, work out F6. If it comes out negative, you know it is compressive. Then F5, transmit this information in the main figure, extend it to the adjacent joint. Go on. Joint C, isolate, show the forces, do sigma Fx0, sigma Fy0, work out the forces, give respect to the sign, transmit it properly to the main figure. Now last joint T, take it out, only one unknown, fine, assume a direction. You can do by solving on any one equation. Say sigma Fy I have taken, solved it, transmit the information, and here as you see we have completely solved the truss, that is worked out all the forces and the reaction by what is called method of joints. Thank you.